Welcome everyone. Thanks for coming to our talk on testing and production. I'm Benji. I'm Benji Weber on Twitter. If you're interested in the slides, we've both tweeted them.
And I'm Alex, and I'm probably fine on Twitter. You probably can't tell because of the font, but that's a 0, not an O there. And yeah, heckle us along. We love to hear comments and things.
We have.
Yeah.
Can you not?
We'll speak louder.
Cool. Who can't hear us?
Okay, we'll speak really loud.
Right.
There are some seats further up as well.
Yeah. Cool. So, it used to be largely accepted that testing your software in production was a sign that you either had a lax or non-existent QA team, or your testing left something to be desired. But now it's becoming more and more common and prevalent that testing software in production is a really good way of getting information about your systems. So today we're going to be talking about the way we've tried to dial up these practices and how we've incorporated them into our software development lifecycle at Unruly.
Yes, so both of us are software developers at Unruly. Unruly is an ad tech company. We're working on fairly interesting problems, from things that have to be very fast, like auctions for adverts to determine who gets to show you an ad when you're loading a web page, through to things that involve processing quite large amounts of data. Unruly is about 170 odd people, and our tech team's around 30 or so. But the team within that Alex and I are in is about 6 people. So when we're talking about our team, that's kind of the size that we're talking about. Within our team, we deploy a lot. We gave a talk last year at Pipeline about our fairly extreme approach to continuous deployment. This is a photo from one of our dashboards of an afternoon. It was a particularly busy afternoon, but it's not that unusual. The overlaid vertical lines are each time we've deployed a service to production. So there's quite a few there. We like to call it discrete delivery because there's still black gaps between the vertical lines. We are an extreme programming team, so we're pair programming on all of our production code. We do test-driven development and various other technical practices. And we're going to talk a bit today about how we apply those practices to continuous delivery and operations in production. One aspect of our extreme programming practices is that we're responsible for the whole development lifecycle, from product planning through to keeping things running in production, which means that our developers are on call. They're the first line of support when something breaks in production. That freedom means we can do some of the exciting things we're going to talk about today. And when we talk about things that we're checking in production, it's ourselves that gets paged when something breaks. And we're responsible for setting up our own rotas and SLAs for these things.
So the talk's going to be split into roughly 2 halves of equivalent size. The first, Benji is going to talk about monitoring and testing in the TDD sense, and how, to us, they are pretty much the same thing. And then in the second half, we're going to talk about how we've been using this safety net of these checks and tests to safely start breaking our production software to get more information about it and inform our software development decisions.
Quick note on tools. We use various tools like Puppet, Graphite, Nagios. But what we're talking about today is applicable to any tools, but we'll give examples with ours. In many cases, I think we can do what we do despite the tooling we use rather than because of it, particularly in the case of Nagios. So I'd like to persuade you that monitoring checks in production and tests for our software as we're building it are pretty much the same thing. What is a unit test when you're writing it? It's a set of assertions about the behaviour of your code that can either pass or fail. What's a monitoring check in production? It's some assertions about the behaviour and or state of your production system that can either pass or fail. So conceptually, I see them quite similar. As we've got better at continuous delivery, continuous deployment, we've found that the checks in production are much more useful when they're monitoring something of business value, whether it's how much money is flowing through the system, or is our production system still meeting its acceptance criteria. That's much more useful than is the server up, or even is our application running. So I've argued monitoring checks and tests are the same. So wouldn't it be great if we can run our tests that we're writing all the time as building our code in production? And indeed, often we can. So this is a little example. We're configuring with Puppet. And we've taken our acceptance tests that we've written in JUnit, packaging them up in a jar, and then executing them with Nagios in production. So we're defining NRPE commands for Nagios, and we're telling it to execute Java, run this jar, and pass in the name of the test to run. And the tests are aware of which environment they're running in. They can run against our production environment. It's just a different URL to hit. So we're literally reusing the same tests. It's also technology agnostic. We've got a team building Angular apps using Protractor for testing, and in the same way they can configure it to run Protractor with JavaScript test spec. So why would you do this? Why would you run your tests in production? Well, there are many different reasons that your production system can break, and deploying new code is only one of them. I think this is one of the reasons why continuous deployment is so valuable, because we believe that your system's going to break anyway. If you're continuously deploying, then you're just in a position to fix it when it does go wrong, inevitably. What are some of these reasons? One of them is time. So we're checking that our system's working as expected when we're releasing it. We might be running the test continuously with a CI server, but that's still not checking that your production system at the points between your deployments is necessarily meeting the same acceptance criteria. For example, we might have clock drift between servers. We've had issues with time zone updates and leap seconds coming in at different times. So time is a constant variable. Users, another pesky issue. We like to think of systems as versions that incrementally change behavior, but often we have big state attached to our systems in the form of databases, and we've got users shoveling in more state that alters the behavior of the system. Users' behavior changes too. So you might have designed your system assuming that users would use it in one way, but at some point they discover they can use it in another way, and your system doesn't scale to handle use in that way, and things start no longer working.
To give a non-software example, the National Grid is quite famous for having policies in place. So, for example, after things like EastEnders or The Voice, if you watch those things, there are policies in place so that the extra amount of demand from everyone going to their kitchen, turning their kettles on, they're able to deal with that. And in a similar way, we can't assume that all of our traffic is going to follow this even periodic pattern. There'll be peaks, there'll be troughs. There will be occasionally massive spikes for reasons that we haven't anticipated, and these are things that can break our system as well. And there's also the layer below our application, so the infrastructure. We use AWS for our cloud hosting, but this is applicable to pretty much any solution that you'll use. So, for example, DNS records not propagating out, or sometimes just returning the wrong value, instances disappearing, or networks having issues. And basically, your entire production system is a ticking time bomb. You don't know when it's going to go off, and you don't know why it's going to go off. The only thing that you can be sure of is that you should pretty much prepare for the worst case scenarios, and that's what we've been doing with our monitoring testing.
So we've argued that monitoring checks and tests are the same thing. We've shown how we can often reuse them in production for monitoring. As we've started doing this more, we've also started noticing we get the same sort of feedback from our monitoring checks in production as we do from our unit tests and other automated tests for our code in terms of design. So the tests give us feedback about the quality of the design of our code, and monitoring checks are giving us feedback about the design of the higher level applications. And we've started calling this monitoring-driven development. So test-driven development, traditionally you've got, red, you write a failing test, then you make it pass, then you do some refactoring. One of the reasons for that is to make it easier to write the next failing test. If you're finding it hard to write the next test, it's probably a sign that you need to improve the design of your application. Last pipeline talk, we talked about how we deploy so frequently to production that we see deployment fitting into this feedback loop. And we deploy, that gives us feedback that informs the next test that we write. But we've come to see it more like this, where we've got an outer feedback loop. So we have our small red-green refactor test-driven development loop there. But the first thing we'll do when we start building an application is write a failing, in our case, Nagios check, but whatever your monitoring alerting system is, for that behavior existing and working in production. Then we'll go through our normal TDD loop, and at some point we will then deploy to production, see that check pass, and then we know that that behaviour is actually working in production. And then we'll go around and do it again. We'll write another check for the next increment of behaviour. And what we've started noticing is just like there are smells that show us that our tests are hard to write and we need to improve the design of our code. There are smells that our checks are hard to write and we need to improve the design of our applications. For example, we often find ourselves wanting to write very repetitive checks and repeating ourselves. Sometimes they're very long, and sometimes we find ourselves having to delve into the private database state of these applications. And we've started noticing these are smells that we should be improving our architecture. So as we've started listening to that, we've started modularizing applications more so we can test the inputs and outputs more easily. And we've found that we've had to publish more data from our applications to our monitoring systems so that we can more easily check the behavior.
So now we have our set of tests at the code level to check all of our things that we want to assert about that. And we have this higher level safety net of monitoring checks. So where do we go from here? What we are interested now is these assertions about our production system. We're interested in staking out points on this map where they suddenly start no longer applying. So for example, if you always want to have a response time below a certain threshold, where does that no longer become the case? At what point does it become too high and your alerts will start going off? And this is valuable information to us. So as part of his Making manifesto, Kent Beck recently said that production is the only truth and that anything else is a simulation. And so we've sort of been doing this for a while. We don't have any environment other than our development machines and production. So really, production really is our only source of truth by our own choice mainly. And we can use this information from our production environments in the same way we get feedback from our tests. We use it to inform the next features that we make and the decisions that we use on our software development cycle. So what kinds of problems have we been trying to test in production? Well, we have one team that's particularly concerned about the amount of throughput they're able to handle. So when the team started up, they had a lot of data from videos and sharing data that they were aggregating in Postgres. And they came across the point where they were no longer able to reasonably do that and had to move to a larger solution, which was MapReduce. And the reason they were able to figure this out was as part of their testing during work hours, they would run the same job that they normally used every night, but with a multiplied amount of data, so one or two orders of magnitude more data. And what this gave us, it gave them a constantly sliding window up on the road ahead of them, saying that, right, we know this will pass if we have 100 times as much data as we currently do. And because they were able to figure out when it started failing, that gave them a good period of 2 or 3 months to figure out, right, how are we going to fix this? So it's not just about using it to build new software, but it's also about how to migrate solutions when they no longer become plausible. I also wanted to include this because I love this picture of Winnie the Pooh. In a similar way, Benji and my team are concerned much more about latency than throughput. So this is a very simplified example of what happens when a user sees an ad on a web page. A request goes off to an ad exchange where information about that is passed out to a number of bidders. The bidders all send their responses back and the winning auction gets to show their content to the user. That ad unit will send data back to a stats platform, which then the bidders will use to inform their next decision. So, for example, you wouldn't want to show the same content to the same user twice, and so it's very important that we keep this fast. And introducing latency at any point during this feedback loop will just keep a cascading domino effect. So if we get slowness here, we're losing money suddenly because we're not expiring stuff fast enough. So in a similar way, during work hours, we multiply our traffic by about 100 times, and we try and send this all through the same pipeline as we normally do. Not only does this let us find out what breaks, but it also lets us really easily find out where the bottlenecks are because of our tight monitoring. So this is, again, a very simplified pipeline. There are services all around this, and we have monitoring at each point, monitor the back pressure, how fast it's processing things. So during these load tests, we can figure out exactly what's failing and scale out appropriately. So a solution that we had a while ago was where all of the traffic was going through a single monolithic app. This information allowed us to realize that we need to shave off bits of that application to smaller apps and scale out horizontally, which has worked for us quite successfully.
So I think this sounds quite risky. We're intentionally sending like 100 times more real traffic at our production systems to see what breaks. But I'd argue it's not for three main reasons. Firstly, all the checks we've been talking about. Because of the way we've been adding those as we build features, we've got a big suite of checks that will tell us when things break. Secondly, we've designed the pipelines for this data to fail in predictable ways using patterns like circuit breaker pattern. Google that if you've not come across it, but it's a way to prevent propagation of failures. And most importantly, because we believe the production systems are going to break anyway, we'd just rather that we do that at a time of our choosing when we're all in the office and can fix it, rather than because the Super Bowl's happened at the weekend and suddenly we've lost our weekend.
We also have situations where if the system can figure out that it's becoming too much, it can stop the load test in its tracks and alert us in that way. So Netflix gets a lot of interest and press about its Chaos Monkeys, its Simian army, to inject infrastructure failures, so isolating EC2 instances, data centers, security groups. And while this is good, we're more interested in failures at the application level that are inherently related to our domain. So I touched on the bidder exchange model, which we use to run our ads. And we have this, each exchange has a pool of bidders that's connected to it. And it's very important to us that it all responds in a very timely fashion. So we've undertaken this self-sabotage, and at the same time, like during the week, when we're all in the office, we deliberately place malfunctioning software into the pool of things that are connected to our exchange. We have to integrate with a lot of third parties. This isn't just at the application level. They have to comply to a spec. We operate to OpenRTB, which is an open specification for ad-based auctions. So even when our third parties are sending back data, we can often be sometimes unintentionally sending back non-compliant stuff as well. So it's not just us, it's not just third parties that fail, it's us as well. So it's for our own benefit, really, that we inject failures into that system. So what kind of things are we interested in? Badly formed data is one. So we have a bidder that randomly permutes data that's spec compliant, but different in a little bit way. So for example, it might actually have the structure that's required, but return a number instead of a string or something like that. And our system have to be able to handle that, because otherwise you're blocking page loads for users, and that's unacceptable. And in a similar way, timeouts are very important to us. The industry standard is roughly 120 milliseconds. But so if we have one bidder that's just too slow and misses that timeout, it immediately pushes everything to the ceiling. And we found a really interesting bug as a result of this, was that the HTTP out-of-the-box client that we were using wasn't disposing of its threads correctly when they were timing out. And so during these controlled demolitions during work hours, we found out that our exchanges were out of memorying exceptions. And this sort of thing would have been catastrophic if it had occurred in our actual outside of work hours. But since we were able to do this in a controlled way, we figured it out and we fixed it. So that's saved us quite a lot of money in the long run, probably. And the way we like to think of this is in the TDD sense of checks versus properties. So the Nagios probes that Benji's talks about assert a particular fact about our systems that we want to be true. So for example, the amount of stuff behind a particular service backlogged, or the amount of money going through a particular system. Whereas by injecting these malfunctioning software that permutes information in that way, it's much more like property-based testing. So you're asserting a property of the system, in our case, that it's able to handle badly formed, non-spec compliant data, or it's able to handle timeouts. And those are the two halves of how we handle our checking and testing in production.
So just to wrap up, we've argued that monitoring checks in production and our tests for our code are pretty much equivalent. We can often use them interchangeably, and both of them give us design feedback, which we're referring to as monitoring-driven development.
And basically, if you don't try and break your software, then someone else probably will. Whether it's intentional or whether it's deliberate malicious sabotage, it depends, but it's best that you learn as much about your system as possible from your production data as you can.
Thank you very much for listening.
Are there any questions? We have some time for questions, yeah?
Yeah.
How did you sell your controlled demolitions to everyone else? Like, was there any resistance?
So by and large, the development team has almost the purview of like what goes on in the software development process. We largely have free rein to do what we think is appropriate, and we trust. So for example, if we had something that's more extreme than we're currently doing, so like let's shut off our main application server and see what happens, it would probably meet more resistance, not just from our product managers, but from the actual team itself. So we're careful about doing this in a controlled way.
The teams have full responsibility over the products. We get feedback from the business about what level of service they require, but it's up to us to meet that.
And play within that box.
Yep.
So have you ever done any tests that cause catastrophic failures, brought the business to a halt?
It depends what you mean by catastrophic. We have had failures that have caused things to break that mean we lose small amounts of money. We haven't had any that we couldn't recover from quite quickly, have we?
So we had last week we had a failure wherein it was the classic domino effect. So one of our services was timing out, and so another service couldn't send data to it, and our Monit, which we use to restart processes, was getting caught in a loop of constantly restarting it, which was disk filling, and so the ad units couldn't write to those servers because they were disk filling. So we weren't getting any stats in, and so we had to follow the trail all the way back.
But even then, it was only affecting part of our servers, and the traffic was being automatically redirected elsewhere.
Yeah.
So, yeah, we have had outages, but not for a long time.
What's the business response when you do something like that and it goes quite badly wrong when you have an outage?
Well, we haven't had an outage that's been significant enough to cause the...
Don't say that. It's going to happen now.
But yeah, neither of us are on call today because we're doing this. So. Anthony.
You didn't mention the term, but I'm guessing a lot of these are canary deploys, where you just deploy one out of a whole bank of servers running different software.
So we have done that, particularly where our software is required by another team. So we have three teams that are kind of in a pipeline. We have one team's responsible for our internal bidders, our team's responsible for our exchanges, and then we have a third team responsible for our ad units, which consumes the data from the previous team. So when we're deploying something that's affecting them, we normally roll it out to a single one and tell them to point your things at this manually. And then if there are problems, then we roll it back.
These are kind of distributed systems, so there's naturally some delay to rolling out across all of the servers. In general, though, we do deploy to all of them at once. There's just a small delay as it propagates to change out. Kelly?
Do you synchronize changes to your monitoring checks with the deployments?
So that's interesting. Do we synchronize checks for the monitoring deploys for the monitoring checks with the applications? I think that's the question.
Sorry,
Yeah.
what I mean is a new instance version of the application with a different functionality which needs a different check.
Yes, so it's actually something we've started trying to do very recently. Traditionally, we've had all the monitoring checks deployed to the monitoring servers from one project, and we've had our applications separately, and yes, we realized that wasn't really working for us. So we've been modularizing our configuration management so that we can have those checks embedded in the applications. We've only started the transformation process, but we believe that's a better way to work.
Yeah.
I think we have to stop now.
So we have to stop now.
But we will be...
in the hallway
we'll wait outside in the corridor if people have more questions. And I sort of quickly mentioned that we're hiring for people to help us be even better at ops, particularly people with expert knowledge of networks and systems. So thank you very much.